So welcome back. Let's go ahead and start focusing now on the delete method we're going to use. So let's go to main here. And let's suppose we want to delete 60, okay, the plane. And the way we're going to do this is we will provide the delete method a key for the node that we want to delete. So maybe something like BR1. Now notice I haven't created this method yet, but it will work in this manner. Delete, and we will supply it, let's say, with 60. And then once it's done, let's go ahead and display it. And we could do it in order, right? So we could do a system.out.println and in order after deletion. We could do something like this, /n, and go over here, br1 dot in order and semicolon here. Now notice delete is red because we have not designed that method. We are going to do that. But the important thing is I want to keep any method here that I use in main, right, as simple as possible. So all complexity is done here in the background. So to match that signature, we need a public void delete, and it will take an int. It will be a key value, so let's call it k for now. Right, so that's the element we're going to compare to the key. And in this method right here, we're going to assign root. Right, so we're going to do, this is the key here. We're going to assign root the return node reference for our private delete method that we're going to create by supplying it the present root. So this will be our future root, will be equal to delete, and we're going to supply it with that k value and the actual root itself as it stands presently. Now obviously this method here does not exist, this delete here with the two arguments. We don't have it, so we're going to do it now as a supporting method. So this will be a private, and notice it has to return a data node, since we're going to supply that to root, and we're going to call it delete, and it's going to have an int k and data node. Let's make it bigger here. Here you go, data node, and let's call it node. And let's put our parentheses here, right? Okay. Now we have a red squiggly line here because we're expected to have a return statement somewhere. Now, what if the node was null? What does that mean? That means it's a base case where we have an empty subtree or tree. Okay, so if that's the case, so we'll start with that first. Node equals null, then we might as well return null. So we have a return statement here, but that's conditional. Notice we still have a squiggly line red at the bottom there. That's because what else can happen? Well, else if, and let's say it just happens to be that one. So node dot get key happens to be k. Well, in that case, we need to ask a few more questions. And let's put curly braces here because we're going to do a couple things here. So first, we're going to check on the right if node dot get right equals null. All right, so what does that mean? We have a leaf. What do we do? So if that is true, then we're going to have to do something with that, which means we're going to go ahead and set the node to its get left. Okay? So let's go ahead and do that. Node is going to be equal to node dot get left. Semicolon. Else, if the node dot get left itself is equal to null, right? Then we're going to do node will be equal to node dot get right. Okay. Else we have two children. So else, we're going to do a whole bunch of things here. So I'm going to open a curly brace. And so there will be, in this block here, we're going to have to replace based on the max value method return. So we need an int, and let's call it temp. This is my replacement, will be equal to max value based on node dot get left. Okay. Next, we're going to do node, and this is where it gets interesting, where we need to set the key based on the replacement. So again, we need to go over here, and we could see here that if we do have a set data, we may need a set key, which we don't have here, right here. So we need a set key to do this. So notice here, because I just remember we had all of this stuff, but we didn't have a set key right here. So let's go ahead and do this. Public, and this will return an actual node, data node, and let's call it set key itself, and int key, and it will simply do a couple things. This dot key will be equal to key, and return this. Just making sure that we have a set key method to do what we're about to do right now. So let's go back to the binary tree here. Okay. And in this case, we need to do node dot set key right here, and it's going to be based on this temp. Next, we're going to go to node dot on the left, set left, and we're going to recursively delete based on temp and node dot get left. Okay. What else could happen? Well, we need to go over here. Else, if node dot get key is greater than k, right? So we need to be deleting the left subtree. So let's go ahead and do that. Node dot set left. We will supply it with the method delete k and node dot get left, recursively speaking. Okay. Else, for this if statement, we're going to go to node dot set right, and we're going to delete k value node dot get right. Okay. So what happens at the end of this method now? Well, we're going to have to return the node, right? Why? Because we're expected to reroute or reroute. Okay, well, let's see if it happens. Let's go back to here and see what's going on. We have br1.delete. We want to delete 60, right? Which is the plane. And let's see if we do get that result. So let's run it. And sure enough, let's see what we had. So we went from, so the first time we printed in order, right? So we had 50 for the car, 60 for the plane. We did an in order again. So we had 50 for the car, 65 for the motorcycle. And sure enough, it deleted our airplane, I believe, which was, plane, which was number 60. All right, so that concludes this series of lessons. And please feel free to go to my GitHub account and retrieve the actual source code. And I will see you then.